They are by far the most terrifying objects in space. The discovery of an ultra-massive black hole sends a shiver down the spine of more than just scientists. A gigantic cosmic devourer, combining more than 1 billion solar masses, already existed so early in our universe that researchers are slowly realizing that these giants play a more important role in the universe than previously assumed. What changes now, when we know that black holes existed even before the first galaxies, and that these black holes were by no means as small as an atom, but contained several billion solar masses? Let's go on a journey to the most powerful, most dangerous, but also the tiniest black holes in the universe. Few people are aware of the diversity of these objects in the cosmos. Even fewer people know that researchers now see black giants as key objects for understanding the entire cosmos. Before the first black hole was definitively confirmed, they were considered pure constructs. They were just mathematical formulas that initially appeared as completely collapsed objects of enormous size in Albert Einstein's relativity equations. In the 1960s, the scientist John Archibald Wheeler coined the term black hole for the first time. And since the discovery of the first black hole, Cygnus X1, we know for sure that these monsters really exist. For a long time, scientists thought that black holes were exclusively the relics of collapsed stars. This also made sense according to Einstein's equations, as he only came up with the existence of the giants because in his view of the cosmos, large, completely collapsed objects had to be the logical conclusion of other, already known objects. If a star dies, it explodes in a supernova, provided it was of a certain size. What remains is either a rapidly rotating neutron star or a black hole. Neutron stars are objects with measurable and highly observable properties, but there are still many mysteries and unsolved puzzles surrounding black holes. The black holes that remain as relics of deceased stars are about 5 to 20 solar masses in size. The first true black hole ever discovered, Cygnus X1, is a good example of this category. It has about 15 solar masses and is now an almost ancient and well-studied astronomical object. Medium gravity black holes reach impressive sizes of 100 to 10,000 solar masses. Even here, we easily reach the limits of our imagination. An impressive example of this size is HLX1 in the galaxy ESO 243-49. With approximately 10,000 solar masses, this black hole has probably grown to this immense size through the merging of several stellar black holes. Let's move on to the royal class of these extraordinary objects. Supermassive black holes combine millions to billions of solar masses. Imagine that our sun weighs about 2 trillion kilograms. A supermassive black hole, therefore, weighs an average of around 30 trillion kilograms. Such black holes are impressive cosmic objects, and we find one of them right in the center of our Milky Way. Sagittarius A star weighs about 4 million solar masses, and M87 star in the center of the galaxy M87 is even larger, combining a full 6.5 billion solar masses. But there are even bigger and more dangerous black holes in the universe. Researchers could hardly believe that the supermassive black holes could be topped, but it's a reality. Ultramassive black holes exist in the cosmos, combining up to 40 billion solar masses. With around 66 billion solar masses, TON 618 is one of the most terrifying examples of this category. This black hole is located at the center of a powerful quasar in the constellation of the Hunting Dogs, about 10 billion light-years from Earth. The galaxy itself has not yet been seen directly by researchers, as its light is outshone by the enormous luminosity of the central quasar. This is most likely due to a gigantic accretion disk that surrounds the ultramassive black hole. The matter in this disk is in the process of being extinguished and shines thousands of times brighter than all the stars in the galaxy combined. But that is by no means all our universe has to offer in terms of black holes. In 2022, the James Webb Space Telescope made a spectacular discovery at the edge of the universe. A black hole that is so old and so huge that it could possibly originate from an earlier universe. Did this black hole survive the cosmic collapse? Who would have thought that these breathtaking discoveries would trigger a complete revolution in our scientific perspective? When the JWST first pointed its high-precision instruments into space in the summer of 2022, it immediately stumbled upon a sensation: galaxies so old and majestic that they took researchers' breath away. But James Webb's cutting-edge and extremely light-sensitive technology not only detected the oldest galaxies ever discovered, but also a black hole so inexplicable that it could change our understanding of the universe forever. Within the galaxy GN-Z11, a black hole has been discovered that is one of the most elusive ultramassive black holes imaginable. Anyone who knows a bit about physics or regularly watches our videos knows that a galaxy with this Z value is 13.4 billion years old. This also means that it's nothing short of a miracle that such an old galaxy already has a black hole at its center that is so gigantic in size. GN-Z11 appears old from our perspective, but 13.4 billion years ago, the galaxy was still very young. The Big Bang was just 400 million years earlier. The quasar was discovered in 2016 by the Hubble Space Telescope and later examined in more detail by James Webb. At Hubble, the researchers were initially unsure whether the data could be correct. The high redshift of Z-11 seemed surreal, as researchers had not previously assumed that finished galaxies already existed in this epoch of space. The galaxy itself, the quasar, and the black hole in the center could be confirmed by Webb's new measurements. A galaxy that was already luminous and magnificent so soon after the Big Bang is already a curiosity, but a black hole weighing several billion suns is a miracle. How can it be that this black hole grew to such an enormous size only 400 million years after the Big Bang? To grow to this size, it would either have had to be born big or devour matter 5 times faster than previously thought possible. In the young universe, however, there could hardly have been any matter in the form of stars. According to the researchers' models, it should have taken several billion years for a black hole to grow to this size. A black hole the size of an atom? We have seen the royal giants and the gods of black holes, which are so large and powerful that they rise above all our mathematical formulas. But what about the smallest black holes? Black holes as small as an atom? Did you know that there are black holes the size of an atom? This is how researchers imagine primordial black holes. These tiny fluctuations could have been created directly after the Big Bang. Initially only the size of an atom, they were probably distributed throughout the universe and merged in the course of cosmic evolution. First, some of these tiny particles merged to form slightly larger black holes. Then these merged with others. And later these black holes may have encountered the remnants of the first extinct stars. This has been the picture of the growth of black holes in the cosmos so far. However, the existence of GN-Z11 calls these models into question. It seems that black holes existed much earlier and in a size that could not previously be understood. One person who may be able to explain the existence of these black giants at the edge of the universe is the British researcher Roger Penrose. Back in 2015, the renowned astrophysicist presented a theory about a cyclical universe in which one universe merges into the next. At the end of a cycle, gigantic black holes have sucked up almost all the matter in the universe. Then there is a collapse, a physically indescribable standstill, followed by a bang from which a new universe emerges. In extensions of this fantastic theory, it could even be possible that the black holes left over at the end are midwives or the birthplace of the new universe. That's crazy, isn't it? Nevertheless, the discoveries of the JWST are currently giving such theories enormous importance. Our old cosmology is simply no longer able to explain what we see in the cosmos. Are black holes really being created in Geneva? Yes, they really do exist. Researchers at CERN in Geneva have confirmed that tiny black holes can be created in their experiments with the LHC. These are formed when particles collide at extremely high speeds in an underground ring. The collision of opposing particle streams leads to fascinating phenomena in matter, which are studied at the LHC. And for tiny fractions of a second, black holes are also created there. However, these black holes have so far only been predicted theoretically. They have yet to be proven with certainty. And if they really do exist, They disintegrate so quickly that they supposedly pose no danger whatsoever. Critics of the project argue, however, that we may not be able to fully understand what effects these small black holes could really have. They consider the experiments at the particle accelerator to be risky and even fear that dimensional gates could be opened unnoticed that could change our reality in a dangerous way. For a long time, it was thought that black holes could be wormholes or tunnels to other worlds or dimensions. Nowadays, such theories are largely considered outdated or disproved. An Einstein-Rosen bridge is a theoretical concept that describes hypothetical connections between different points in the space-time continuum. Other scientists speculate that black holes in a mirror or parallel universe could act as white holes, recycling the matter that is sucked in here. In practice, nobody knows exactly what goes on in a black hole. Theoretically, we know that the actual black hole is a point of infinite density, which is mathematically difficult to grasp. But matter in black holes must be possessed or stored somehow, as quantum physics has established that matter in our universe can only be broken down into its information components, but can never be completely destroyed. So, do black holes collect vast amounts of information in their interior? If so, it would of course be interesting to know what happens to this information. Perhaps Roger Penrose was right in his assumption that black holes are something like the keepers of the universe when matter has lived out. They store the information of the cosmos, and when a new cycle begins, they spit out all this information again, from which new stars and new galaxies then emerge. Subscribe to the channel now and be part of every new video.